Good day, students. My name is Mrs. Cynthia Strijdom. You can refer to me as Mrs. Strijdom or ma'am, like some of you prefer. And I'll be your lecturer for MFP this semester, both the MFPASE2 students and the campus-based students. Today's lecture is an introduction into the module, and I just wanted to introduce myself to you and just say welcome to this module. I just want to make sure that you guys all have the Moodle app on your phones. It's a more convenient way to quickly check in, to receive notifications regarding the module, and to maybe send me a message. So in today's lecture, we are going to do a quick introduction, as we are currently busy with. Then we are going to look at number sense and what the concept is about. We are going to look at reasoning, fluency, and flexibility, just a broad overview and how it relates back to number sense. Again, it's going to be an introduction. We are not going to go into much detail. We will do that in the weeks to come. And then we are also going to look at the South African context and what the TIM study has to say about maths in the South African context. We will take a very broad overview of the weightings in CAPS regarding number sense and the concepts related to that. We will look at a video about your role as the teacher, and then also, well, you can't see that, my face is in the way, but then we'll also quickly look at an overview of the module. Right, so this is an introduction to week 1. The 4 main things that we are going to look at is, firstly, we are going to define number sense. We're going to look at the concepts that falls within the framework of number sense. We are going to look at fluency, flexibility, and reasoning and how that ties into number sense. We are going to look at your role as a teacher, and then also, as I mentioned, a brief overview of the module and the assessments to come. Right, so we started with number sense in the class, and we did a think, pay, share activity where we firstly individually thought about how we would define number sense. I know you had a subject last year where you touched on the basic principles of number sense and counting. So just think back to last year and just in general what you know about number sense. How would you define it? For this activity's purpose, you can just think about your definition, or you can pause the video and then write your definition down, and then you can compare it to what I have written about the definition. If you Google number sense or ask ChatGPT what number sense is, you will see that there are various definitions to define number sense. So I distilled all the definitions I could find into the current one that you are seeing on the slide. So I'm going to read it to you. Number sense is the ability to understand numbers, the patterns they make, and then apply that understanding flexibly, fluently, and creatively to solve problems. Now, the problems that I'm referring to isn't simply just word sum problems. It's any mathematical problem in maths, but referencing the context of this module, it'll be problems within number relations, and number operations. So when we look at number sense, the developmental progression of number sense is very crucial, and it occurs from grade R, actually from before grade R onwards, and it involves core areas as I just mentioned, number relations, and number operations, and we will be looking at those individually in this lecture and then in the lectures to come. Right, so as I just mentioned in the previous slide, the development and the progression of number sense is very crucial. Here is an example of how number sense develop. This is for a simple calculation such as 6 plus 9. So if a learner, and this is mostly in grade R and at the beginning of grade 1, so learners will count 6 counters, and then they will, in a separate group, count 9 counters, and then they will start from the 6 counters and start from the beginning and then count all the counters so that they get to the answer. Then if a learner has a bit more developed number sense, they will take the 6 counters, they will know it's 6, and then they will just count onwards from 6. So then they will count 9 counters, but they will say 7, 8, 9, 10. So they will have the 2 separate groups, 6 counters, 9 counters, but then they won't start from the beginning of the 6 counters. They will know it's 6 and then just count onwards. Then if a learner has a bit more developed number sense, they would think that 9 is a bigger number, so it's easier to start from 9 and then count 6 onwards. And then learners with your most advanced number sense will break the numbers up and then mentally compute it. They would say, right, I have 9, let's make it a friendly number, 10. So I take one of the 6, add it to 9, it becomes 10, and then I have 5. So 10 plus 5 equals 15. So when we look at number sense, we look at 3 key components: number relations, and number operations. So number sense is a child's knowledge of those 3 areas, and it involves both verbal and written symbolic representations. So when we look specifically at number, we are going to cover 2 key areas. The first is number names and symbols, and how we develop that from grade R to grade 3, and then we are also going to look at counting extensively. So number relations refers to how numbers are connected, and as well as the patterns between numbers. So there are 2 components here: the relationship between operations, so between addition, multiplication, subtraction and division, and also comparing values to each other. But if you take 2 numbers and you compare it to say which is less, which is more, which is equal to, those are the 2 main components of number relations. So if we look at number relations, it helps learners to recognize how numbers are connected, to see the patterns between numbers. And then if they know how numbers are connected, it'll help them to manipulate numbers. For example, to use number bonds to calculate a problem, and to use a strategy that's more efficient and easier to calculate. If they do not know how numbers are connected, they won't be able to manipulate the numbers. So number relations is very critical for a good number sense development. The last component of number sense that we will be looking at in this module is number operations. So number operations is basically your four operations, your four basic operations, and how they relate to each other and how they are used in basic arithmetic and calculations. So arithmetic is very important. We will discuss it later on in the module. Counting is seen as a key component for developing number relations and number operations. If a learner's sense of number, their sense of muchness, as we will discuss later on, and counting abilities is weak, they will struggle to relate numbers with each other or to each other, as well as struggle to grasp the basic ideas of and concepts of operations. So knowing how numbers relate to each other can be used to do number operations more efficiently. And also the development of calculation fluency is highlighted through adaptive counting and decomposition strategies, as we will discuss later on in this lecture and module. So these are just a few ideas as to why it is important for learners to develop a strong number sense in the foundation phase. You can read those pointers, but I will discuss each one briefly. So a strong number sense underpins fluency, reasoning, and flexibility, allowing learners to tackle more complex problems later on in maths. Learners with a good number sense can estimate more accurately. For example, if you show learners a pile of counters, learners with a logical sense of number would estimate that it cannot be 1,000,000 counters, nor can it be only 2 counters. So they would estimate more closely compared to someone whose number sense is underdeveloped. They can compare, calculate more efficiently in both academic and real-life contexts. The intuition about numbers helps them to recognize their errors and choose more appropriate strategies to solve problems and to calculate. It enables learners to break down problems, recognize patterns, adapt their methods, and they are better with everyday tasks such as time management and, well, if you're an adult, budgeting, because that all relies on a good number sense, a strong foundation in number sense. So this is a diagram that I made for you to show you what we just touched on. We looked at the 3 key components of number sense, which is number relations, and number operations, and we also will look at flexibility, fluency, and reasoning, and how those 3 are intertwined in those 3 aspects of number sense to develop a strong sense of number during this module. So when we look at reasoning, we look at the process of how learners justify their decisions to solve a problem or the strategy they use to do a calculation. So in order for learners to reason, they need to understand the underlying concepts and to make sense of what they are doing. Otherwise, they won't be able to explain why they chose to use a certain strategy. Reasoning, I think, is also a component that we do not really make time for in the foundation phase. With a full curriculum, we tend to just move on as soon as someone gives the correct answer. We need to take the time and let learners allow them the space to discuss their choices and decisions they made regarding the problems they solved. We will be looking at reasoning through the lectures to come. So why is reasoning important? Why do we need to take the time to develop reasoning in mathematics? Here are just a few key pointers. There are loads more examples of why it is important. So learners need reasoning to identify the connections between maths and the concepts in maths. They use it to break down problems into more manageable parts. They use reasoning to justify their decisions and the logic behind the decisions they made, and also to generalize patterns to new or broader contexts. Here is a very brief example of reasoning within number sense. So a learner, while doing a calculation, they notice that the sum of any two odd numbers is always an even number, but they are able to reason as to why this is true. And they do that by exploring the properties of odd and even numbers. So next up is fluency. Fluency is a learner's ability to do operations accurately, efficiently, flexibly. It is, however, not just the speed and correctness, but also the deep understanding of numbers. So it's not just the ability, let me just say that correctly. It does not only refer to procedural knowledge of learners, but also conceptual knowledge. So not only can they perform the correct procedure to calculate the problem, they also understand why, so the logic behind what they were doing. And when I think of fluency, I must admit I don't really think about a part of fluency as also understanding what you're doing, but that is very important, and we will look at that in the module. So just a quick example again, when learners solve a basic calculation that's not in context of a problem, 25 times 4, a fluent learner might reason to say that 25 times 4 is 100, but they will also recognize that 25, if it goes into 100 4 times, we can then refer to 25 as a quarter of 100. So not only will they be able to quickly do the calculation, they will also be able to understand what they just calculated and then relate that to other contexts as well. So again, here you can see that fluency is not only just the ability to be quick with your calculations, to know your multiplications table very quickly, or to do mental calculations with ease, although that is a very big part of fluency and enhancing fluency. It's also being able to use multiple strategies to solve a problem, and to understand those strategies and to make connections between concepts in maths. So flexibility refers to a learner's ability to approach and solve problems using various methods or strategies, and to adopt their strategy, to change their strategy that they are using when they see it's not working or the number range is too large, so they need to think of a new problem. So it's all about being flexible and willing to change and adapt your method for a more efficient approach. Also, again, just as with fluency and with reasoning, a very deep understanding of the concepts is necessary for a learner to be able to be flexible in their approach to problem solving or calculations. So here is a quick example of flexibility in maths. To calculate 98 plus 47, a learner can use compensation. So they can say that I know 98 is close to 100, so let's add 2, and then it's easier to say 100 plus 47, but then we take away the 2 that we added, so we get 145. Or they can break numbers apart. They can say 98 plus 40 plus 7 equals, so they plus the tens first, and then they plus the ones, the units, to get 145. So this section touches on the advantages of a strong development in fluency, flexibility, and reasoning. Please scroll through the slides and read the various benefits that it holds for a good number sense development. If I can just touch on a few things, these three components is very important to develop a conceptual understanding in mathematics, and for learners not to only rely on rote memorization but to really know what they are doing. That will help set them up for more abstract maths later on in the intermediate phase. So that is why we are going to look at how to develop fluency, flexibility, and reasoning in the foundation phase within number sense as it pertains to number relations, and number operations. So in this table, I just compared the three key areas that we are going to focus on so that you can see an overview of the definitions, what we focus on within each area, and then what skills are involved. So you can just read through that summary. So looking at the three aspects of reasoning, fluency, and flexibility, I think you would have noticed by now that those three are intertwined in mathematics and supportive of each other. I just want to quickly touch on the primary goal of reasoning, fluency, and flexibility. So for reasoning, it's to develop critical thinking skills, to be logical in your approach to problems, or be logical in the strategy that you use to calculate. That's the primary goal of reasoning. And for learners to be critical in their thinking. Then for fluency, we want learners to be efficient and accurate, and they shouldn't take all the time in the world to complete calculations. So we want them to be proficient in performing the operations. And then flexibility is to ensure that the strategies they use they are adaptable in their approach. They can change the approach if they see it's not working in the given context or with the number range that they are working with. They can think creatively outside of the box, be able to solve the problem. So I hope you had a chance to read the TIMS report. According to TIMS, that is the Trends in International Mathematics and Science Study of 2019, they reported that South Africa is ranked at the bottom of the list with our mathematical achievement in grades 4 and grade 8. So yes, we are really facing various challenges in mathematics education in South Africa. However, a few of the challenges informs the way we teach and what we focus on as foundation or future foundation phase teachers, and that would be the curriculum that emphasizes routine problem solving rather than cognitive or higher cognitive skills. So if we put that in layman's terms, we do not teach for understanding. So in the foundation phase, and I can attest to this, we focus on procedural knowledge way more than we focus on conceptual knowledge. So if we look at the TIMS report, there's two key takeaways for us. The first one is that learners really need help understanding the mathematical concepts. And then, so just as I mentioned before, we need to focus less on procedural knowledge and more on conceptual understanding for learners to grasp the concepts. And then the second one is that we need to prioritize higher cognitive thinking skills. So when you look at the curriculum, this is the weighting of the content areas in the foundation phase, grade 1, 2, and 3. If we look at numbers, operations, and relationships, this is the area that we are focusing on in this module. We can see that it's 65%, 60% for grade 2, and 58% for grade 3. That's the weighting content. So the majority of the focus is on number, operations, and relationships. And I want you to take just a minute to think about why. Why is the weighting so that the rest of the content areas is way less than number, operations, and relationships? Why do you think that is the case? And do you think we can justify the weighting of these content areas? So when you look at the video in the next slide, I want you to think about how your role as a teacher has changed and how it is reflected in the 21st century, because your role is going to influence your beliefs about you as a teacher and how you approach learners in the classroom. This is a summary of the structure of the module. It's also in the study guide, and this is just to show you what we are going to focus on, the topics for this module, and as well as important dates that you should be aware of. Again, it is structured in the study guide, so please take a look at the study guide. So we covered an introduction and an overview of the main concepts that will underpin each lecture moving forward. So just take note of that and make sure that you start to understand the various concepts and how they relate to each other. So lastly, from my side, I want to tell you about a very great tactic that I used, unfortunately, only later on in my teaching career. After teaching learners a concept, don't ask them, do they have questions, or if they have questions. That elicits a yes or no response. However, if you rephrase the question to what questions do you have for me, it opens up the playing field and allows learners to feel comfortable to have questions. So please let me know what questions you have or remarks, if any, regarding this lecture. On Moodle, I will open up a link where you can jot down your remarks or questions, and we can discuss those in the check-in sessions. From my side, please make sure to see the consultation hours or the check-in sessions on Moodle. It'll be every second Wednesday, so make sure that you take notes, write down your questions or remarks regarding the lecture and the content, and we will discuss those in the check-in sessions. Have a good day further and enjoy the rest of your week. I will see you soon. Bye.